This final lesson in the series on drag consists of a summary of the main points. As a reminder of the divisions of drag, here is the family tree. Parasite drag is made up of skin friction drag, form or pressure drag, which together are known as profile drag, and interference drag. Parasite drag varies as the square of the IAS. If you double the speed, you get 4 times the parasite drag. If you halve the speed, you get 1/4 of the parasite drag. Designers can minimize parasite drag by streamlining, incorporating fillets and fairings, using laminar flow wing sections, and minimizing frontal area. Flight crews must ensure that the airframe, and particularly the wing, is not contaminated by ice, snow, frost, slush, insects or mud. On induced drag, you will need to remember the following key points. Spanwise airflow generates wingtip vortices. The higher the CL, or the lower the IAS, the stronger the wingtip vortices. Wingtip vortices strengthen downwash. Strengthened downwash inclines wing lift rearwards. The greater the rearward inclination of the wing lift, the greater will be the induced drag. Induced drag varies inversely as the square of the indicated airspeed. If speed is halved, the CDI will increase by 16 times, and the induced drag by 4. If speed is doubled, the induced drag coefficient will reduce to 1/16 of its previous value, and the induced drag to 1/4 of its previous value. Designers can minimize induced drag by using a high aspect ratio planform, using a tapered wing planform with wing twist or washout, and/or spanwise camber variation, and by incorporating end plates, tip tanks, winglets, or tip shaping. Total drag is the sum of parasite and induced drag. Total drag is a minimum when parasite and induced drag are equal. At low IAS, induced drag is dominant. At high IAS, parasite drag is dominant. The IAS at which the two component drags are equal is called minimum drag speed, VMD. As gross weight decreases in flight, induced drag, total drag, and VMD all decrease. At a constant IAS, altitude has no effect on total drag, but TAS will increase as density reduces with higher altitude. Configuration changes, which increase the parasite area, such as landing gear, flaps and speed brakes, increase parasite and total drag, but reduce VMD. An aircraft flying at a steady IAS higher than VMD with a fixed power setting will have speed stability. An aircraft flying at a steady IAS at VMD or slower with a fixed power setting will usually not have speed stability. If an aircraft at a steady IAS at a fixed power setting within the non-stable IAS region encounters a disturbance which slows the aircraft, it will tend to slow further. IAS will tend to continue to decrease and the total drag to increase. The IAS for minimum power required, VMP, is slower than the minimum drag speed, VMD. Maximum TAS to power ratio, which is 1.32 VMP, occurs at VMD.